Hello everyone. In our earlier video, the introductory video of negative exponents, we initially assumed that a raised to the power minus 1 was just a symbol or a notation to represent 1 by a, and later on for the end of the video, we justified that negative exponents can also be used to represent very small numbers, and this was even generalized, saying that a raised to the power minus n can be written for any 1 by a to the power n, where this n is positive. If it's in the denominator, the a raised to the power n in the denominator can be expressed as a raised to the power minus n. And now we'll have to see that, so since we have acknowledged the existence of negative exponents, we'll have to see whether all these laws of exponents which we had logically arrived at in the case of positive exponents are applicable here also. So that is what we are going to establish in this video, that those laws of exponents. For example, the first law which we saw was a to the power m multiplied by a to the power n. That is, the bases were the same and the exponents were different, and in that case the exponents were positive. We had proved this for the positive exponents. For just whole numbers, m and n were whole numbers. Then now we are seeing for m and n are integers, positive, negative and 0. So this was equal to a raised to the power m plus n. Now let's establish this fact for negative exponents also with examples like we did before. So let me consider this example. Say we'll start with small numbers. 2 raised to the power minus 4. This is just it stands for 1 by 2 to the power 4, isn't it? And let me take with the same base. Of course, we need a number with the same, an expression with the same base. So 2 raised to the power minus 2, which is 1 by 2 squared. Now, does this law hold here? Let's see. First of all, let's see what these two, when multiplied, gives us. Brown. 2 raised to the power minus 4 multiplied by 2 raised to the power minus 2. What does this give me? As I said before, 2 raised to the power minus 4 is 1 by 2 to the power 4, isn't it? So I can write it as 1 by 2 repeatedly multiplied 4 times, but in the denominator, multiplied by this one. 1 by 2 multiplied twice, 2 into 2, which is equal to 1 by 2 multiplied 6 times, isn't it? 4 plus 2, 6 times. So this is equal to 1 by 2 raised to the power 6, or we can conclude that 2 raised to the power minus 4 into 2 raised to the power minus 2 is equal to 2 raised to the power minus 6. Now let me do the same problem using the law of exponents and see whether it gives us the same result. So this is 2 raised to the power minus 4 into 2 raised to the power minus 2 should be equal to 2 raised to the power minus 4 plus minus 2. If I apply the law, because what was the law? A raised to the power m into a raised to the power n is equal to, you are adding the exponents. When the bases are the same and when you are multiplying, we add the exponents. So here also we have added, and the result we obtain is minus 4 plus minus 2 is minus 4 minus 2, which is 2 raised to the power minus 6, and we have obtained the same result. So the law of exponent holds good for the negative exponents also, but let me check once again, because here both the bases were positive. So let us let the second example be, this was our first example, let the second example be a negative base, and a negative base which is minus 4, and this time let one of the exponents be positive. So minus 4 into, let's say this is minus 4 raised to the power 2. So we have taken such an example that the base is negative, the base is common but it is negative, one exponent is negative and the other exponent is positive. So let me simplify using the normal method without the involvement of this the law. So this is minus 4 raised to the power 3 into minus 4 raised to the power 2. So I can in fact use the division law of exponents here, because this is actually minus 4 squared by minus 4 cube. So I can say this is equal to, because I have positive exponents now, isn't it? Both of them are positive exponents, and we have established the logic of division law here. So this is minus 4 raised to the power 2 minus 3. So what is 2 minus 3? It is minus 4 raised to the power minus 1. Right? Now let me do the same problem using this law. What was that? A to the power m into a to the power n should be equal to a to the power m plus n. So let me apply it here, even in spite of it being a negative exponent. Let me just apply and see if it holds good. So this should be equal to minus 4 raised to the power minus 3 plus 2, right? The whole thing raised to the power minus 3 plus 2, which would be equal to minus 4 raised to the power minus 1, which are the same. So I think at least the product rule, or when you multiply exponents with same basis, the powers can be added, is established now for negative exponents also. Right? This rule is established now for all m and integers. M and n stands for integers now. Minus, positive, negative and 0. Now in the same process, let's verify, or I think I leave it to you all for verifying the other laws which we had established only for positive exponents. Check it for negative exponents also, whether it is applicable, whether these laws are applicable for negative exponents. The first one, a power m by a power n is equal to a power m minus n, whether it's applicable or not. And the power of power rule, in fact we had applied this second rule in our introductory video itself. If you remember, we had written a to the power minus 1 the whole power n, and we had used the rule, but just check it with numerical examples for your own satisfaction. And the third one, when the bases are different but the exponents are same. So when the exponents are the same but the bases are different, we just multiply the bases and raise it to the same exponent. This logic can also be checked for negative exponents. I hope you follow, and I hope you will carry out this exercise on your own. Thank you, and let us proceed to do some more examples of exponents, this time involving negative exponents also. Thank you.